Right, our next talk is from Sasha Plavin about Accessors.jl Beyond at Set, or a tour of the opticland. Please take it away.
Yeah, thanks everyone for coming. And Accessors.jl is quite a popular package. You might have seen at set macro in other packages in end user code elsewhere. But even though it's a popular package, I would say that it still has some features that, in my opinion, are underused, and I will talk about them and the overall design and what it is, really. So just to clarify, it's not optics in the physical sense, so it's not like we take a beam of light, do something with it. It's not this kind of optics, but optics is just kind of term in programming for functional references. I won't assume the knowledge of like either optics or Accessors.jl in my talk. I will give like intro as well. And the plan of our tour will be like what is it, why it was Accessors.jl was introduced, how it works roughly. I will overview a few kind of nice, common and neat use cases and discuss some design questions as well. So this is the Accessors.jl package. It is, so the very kind of basic APIs that you might have seen being used is kind of just operating with immutable structures as if they were mutable. So of course you cannot do kind of name tuple dot some field equals something, but you can make a copy in a convenient way using set macro. It looks almost exactly the same as working with mutable structs, but it creates a copy. So Accessors.jl, it's pretty old. I mean, it's been developed for many years, and the original main author is, and he's still active, JW3126, and since about 2022, I've been doing a lot of bug fixes and new features and cleanup as well. So first of all, how it works. Of course, there is no magic. I think I'll try actually. Oh, I guess it's kind of stuck here. So there is no magic. When you see at set and some property setting, it just expands to regular Julia code. Everything is kind of clear and can be explored with macro expand. And the property lens implementation is also pretty short. It just gets get property and calls set properties on set. So from just this example, I would say it's not really clear why would you use accessors at all if you have these nice functions like get property, set property. So there are a few key features, and they really kind of circle around all kinds of like composability. So accessors is generic. The idea is that set function and set macro, they aim to support all functions, not just property access. Wherever it makes sense, you can make like set first element in our array equals 100, and it returns you a copy of the array with this modification done. You can set a year of a date or like a lot of other stuff. The idea is that it should work for any function where it kind of intuitively makes sense. And what accessors brings you is, in addition to supporting a lot of these functions by default, is also composed functions are supported. So you can have an object with nested fields and nested arrays, nested elements, and modify something very deep within this object and return a copy of everything. So this makes operating with immutable structs very convenient, and they are still performant. And in addition to, just, of course, the set macro may provide a convenience interface. Instead of writing these composed functions just by yourself, I would say this is as convenient as it can in principle get. You just set whatever function, like arbitrary function you have of your object, and it returns you a copy. So this is the basic kind of promise and aim of accessors. It has more stuff, more involved stuff that maybe you want to modify several objects at a time, maybe you want to insert, delete. I would say, so I won't stop much on kind of parallels to other languages, but I think in Julia, at least for me, it was kind of the only language where I found it like really useful in day-to-day work. Yeah, and there is even more. So as I said, there is like not just set, but modify, insert, delete, get all, set all for multiple values. I have an Accessors extra package. From time to time, something is upstreamed from there if it is generally useful and can be implemented cleanly, but kind of not everything that is useful is upstreamed yet. So then I guess to the kind of nice part, probably more, and the kind of part that doesn't require any understanding in advance is that what would you use it for? So I would say that I personally use accessors for like for everything really. So the base idea is that if you want an object just like the object you have with just some arbitrary function, nested, simple, complex, anywhere, it doesn't matter, change to a new value. That's just add set to a new val. And there are just kind of some examples. Maybe you want to you have all, if you have all the structs that are immutable, or you don't want like race conditions, so you can just change nested properties. You can change like nested arrays, nested objects in any way. I would say this is kind of just how you would intuitively think about modifying an immutable structs. You want the same object, just with something inside it changed. It can be property or a function. More advanced stuff includes recursive optics and manipulating, for example, all objects of some type within your structure. So, for example, if you have your object where you have different geometry primitives, some of them are polygons, you can triangulate all of them at once, and you will get back the same kind of object with all polygons replaced with their like triangulate calls. So if you have a JSON object and you want to convert everything to dictionaries, not dicts, you can do it the same way. You can just select all the recursively select all JSON objects and apply the dictionary constructor to them. It just works. It's convenient to work with expressions because they are fundamentally nested objects. So here you can define, okay, like I want to select all sub-expressions that kind of follow this condition and extract them. So all kinds of this work. Another kind of use cases is really using and defining the API of your packages using the set function. So it is generally common, not just in Julia, to have some function and being able to get and set this function of an object. And very often, I mean, not extremely often, but from time to time, I see it being defined as like f and set f. To kind of save the user from learning different functions like f and set f separately, consider defining f and the accessor's set function with it. There are some examples in the ecosystem, like in the interval sets. Maybe you want to modify the left endpoint of an interval, set it to some value, and return another interval. That's really the API for that. In some kind of numbers with uncertainties, you want to modify the value or uncertainty. That's also how you can get it with set. In axis keys, you have your regular keyed array. Want to modify axis keys for some axis and return the resulting, like the new array back. That's how you get it. So I would say that it just makes sense as the API for a package if you consider having these two functions for immutable structs. Just replace the set f with the accessor set function. Regarding more kind of specific use cases, neat one is you can have mapped arrays with automatic support for modification, for set index, for push. There is a map view so you just pass, instead of just a lambda function, you pass an optic here that selects the A property times 10, and you can set, if you do set index on this array, it modifies the original array because it knows what is selected in Y and how to get back from Y values to X. I think this is kind of the cleanest way to get automatic modification on a mapped array. you can use it in differentiation. Everything in Accessors is type stable, performant, and like a lot of effort is paid to that. So the top line is just the definition how you like this is really the implementation if you want to find the derivative of some arbitrary function taking an arbitrary object at some value of its object. And this is a usage example. So this is a function that just your regular Julia function. The next line is what is the input object you want to differentiate in. And the third line is with respect to what part of this object you want to differentiate. The same, of course, works with gradients. Yeah, with any kind of structs, accessors, and packages it's built on, they pay also a lot of attention to be as generic as possible. Another neat use case is, so let's say you just define your kind of model or a struct that you can evaluate. Here it's just your regular Julia code, no accessor stuff whatsoever. And if you define what what properties of your functions, like they can be nested, there can be multiple of them. If you can define like what properties you want to adjust, then there is just a small convenience function that gives you this whole UI with all the sliders and stuff. And this is really built on being able to get and set the values specified by optics. So it does work. I use it just kind of for exploratory stuff. It's still work in progress. Maybe some functionalities has limited support, but I already find it like very useful and seamless. Also, there is Pluto support, but talk to me if you're interested in that. Of course, if you don't just want to play with parameters of your model, you can do optimization. The only change here is that we define the log likelihood function, and then I highlight in bold that we pass it to the accessible model. To the accessible model as the first argument. That's it. Nothing else in the model definition changes. The struct stays the same. They can be your arbitrary Julia struct. No need to kind of like specialize or like use some annotations in there. And here, your log likelihood and all your kind of model definitions, they don't care about flattening to vectors. They don't care about reconstructions. You don't think about the vectors at all. You just think about your struct. How do you compute kind of loss or likelihood or whatever, and then you can just pass it to optimization.jl. It's a very thin integration layer that gets you your kind of model back. It doesn't get you back the vector, no need to stop at optimization. You can do MCMC with exactly the same definition of the model. You also specify what are your priors on which argument. And so now I only support pigeons, but it's a very thin integration layer. And again, as a result, so you don't work with just raw vectors of parameters anywhere. All your functions and the result as well, this is just your model, your model with different values plugged into it. So it is implemented in accessible models. Probably I should register it soon. This is very thin. This is like a really very thin wrapper around accessors. With all the Maki optimization and pigeon support, it's about 100 of lines total. And most of them, of course, are in package extensions to do these kind of connections between the actual object and the API of like Maki optimization pigeons. Integrations are easy to add if you, like, I guess maybe Turing makes sense as well to work with more samplers. So it is really should be trivial to add, and it's real nice to have the same model definition. First, you play with parameters interactively, then you quickly optimize the values, and then you can do Monte Carlo sampling, always the same model definition. So. There are kind of other use cases. I was given a Maki Extra talk yesterday, but basically it uses optics. If you define kind of mapping from your data to plotting attributes like X, Y, color, with optics, it can both give you automatic axis labels, because I mean optics know how to stringify them. And also you can get these interactions automatically because objects know how to change a value in an object. They know how to create create new objects out of these. Yeah, I would say this is kind of just follows from what optics are. It works very nicely. And I think this will be the last kind of specific use case. It's given that optics are kind of just functions that are not opaque, like lambda functions, but inspectable. Kind of, they are just objects like composed function and base fix and whatever. There is also a thin layer, SQL collections.jl, that converts kind of. This is code using just everything in memory, using kind of base Julia functions and CSV reading. And this is just with very tiny modifications. You kind of just add O here from accessors. It works without loading all the data set into memory. It works just converts it to SQL and only materializes the final result. Here, it's kind of uses only a part of optics. It doesn't use set at all. It just uses @o macro as a neat way to create introspectable functions that you can then nicely convert to SQL. So that's it about use cases. And my final part of the talk is the design, performance, and a bit on the future of accessors. So the main kind of constraints that we work with in accessors is to make it really zero cost everywhere where it's possible. It should be seamless, and it is seamless for users. Although it's sometimes very tricky to actually make it work. Because optics, so if you have several composed functions and you want to set or modify, it needs to unwrap all these kind of chain of functions, and it heavily relies on recursion and the compiler being able to optimize this recursion. So whenever there are some changes to Julia compiler heuristic and limitations, I mean, they don't break performance test in accessors that often, but sometimes it happens. And we need to take special care, and we do take that, to kind of limit the recursion to a minimum. Sometimes we have to kind of forgo straightforward implementations that should work in principle, but they are very slow in practice because of compiler heuristic mostly. Some cases of where it's difficult include especially like set all, so like setting multiple values, and recursive optics. They are really hardest. We haven't found a better way other than using multiple evals in a loop, or there is this kind of hash self-hash trick that works for some recursive functions as well. So if you are if you can help with making this code cleaner, avoiding generated functions, evals, and other hacks, and still keeping the performance, yeah, I would be happy to chat with you. Yeah, so that was the example of @eval calling @eval in a loop, and this is an example of where we need to use hash self-hash trick that I just randomly learned about from some discussion at functors.jl. Yeah, and this is kind of my summary. So the idea of accessors is whenever you want an object like the one you have, just with some part of it, like arbitrary part of it defined by some function, modified, that's just @set for any kind of reasonable function. The idea is to support as much as possible. It doesn't actually take a lot of effort. And this simple idea, it leads to really wide applicability. So I've shown these use cases from kind of different fields of Julia kind of usage, and a lot of natural extensions to accessors. The design is kind of aimed to be easy to use. I think it works. It is composable. I think kind of really impressive how it's possible to make it composable and not sacrifice performance, but it works and works stably. It is made, this composability and performance are made possible by the Julia semantics, the multiple dispatch, of course, and the compiler optimizations. We crucially rely on compiler optimizations because accessors are often used in hot loops, like in optimization or elsewhere. And this means we could really use some more direct control on the compiler heuristics, such as recursion limits. I think I asked about that like on either Slack or GitHub issues at some point, but yeah, I guess it's not trivial to add either. That's mostly it, just kind of like a glimpse into potential near future. So there is a single most requested feature in Accessors, is to set multiple parts of a structure at once in one call of set or something. Currently, there is no kind of dedicated support for it, so you can just use whatever piping package whatever generic piping package you like with at set, and it works. There are some proposed variants on what syntax we can use to set multiple properties or multiple functions at a time. This is still kind of not decided, but really we regularly, definitely every year, maybe even more often, get a request of something like that. That's it from my side. Happy to answer questions or follow up with discussions afterwards. Thank you.
May I ask when a function f is unreasonable?
So sometimes you cannot just, it just doesn't make sense to ask a question, okay, like I want the object with f set to something like, I mean, if your f is, I don't know, your, let's say you define a loss in optimization, right? And you cannot just say, okay, like set me the loss of solution to -1 or like to 0. It just doesn't make sense. This is a kind of simple example, but also, I don't know, read file or like read doesn't make sense to set, right? So I'm talking about like these kind of functions.
How are you actually quantifying the cost of your abstractions? You said zero cost abstractions. Do you have like tests for that?
Yeah. There is like a separate file with tests, like specifically performance tests. They are both tests that everything is inferable, that there are either no allocations when there should be no allocations, or as many as if you would do the same thing manually. And there is also benchmark tools used in there. That's why from time to time, of course, for random fluctuations, we need to rerun CI, but generally it works pretty stable, and we immediately catch if something is broken in the Julia update.
Yeah, I'm really glad you touched on the the struggle between user convenience and developers. I would call them like investments, because it gets more and more convoluted and becomes harder and harder to maintain. And how do you kind of do the policing? Like whoever contributes, you have to make sure their contributions up to the standard.
So for any kind of non-trivial functionality, we always add the new performance tests. But generally, you just need to keep an eye on that. If you just remove the performance test and wait for like 3 years, a lot of will break on the new Julia version. But if you do it like kind of whenever new version comes out, there are almost always just like some tiny changes needed if needed. So I guess we manage.
Yeah, but you're introducing more and more tricks, and it gets harder.
So actually, like most of these use cases, at least, they don't touch on the actual kind of underlying optic implementation. They are just thin wrappers around. Like for example, like accessible models, it just uses get all, set all, whatever from optics. And it doesn't implement anything itself. That's why it's only 100 lines of code. What else? Kind of like all these use cases, they just realize that Accessors.jl that it's performant, and it compiles to the same code as if you do the same manually. That's why kind of dependent packages, they don't need to care about it.
Yeah, thanks. Any other questions? If not, let's thank Sasha again for the wonderful talk.